Hey there, welcome to the Electronics Lab. In this video, I'm going to talk about Kirchoff's current law. And Kirchoff's current law applies to electrical circuits, and it says that the sum of the currents into a node is equal to the sum of the currents out of the node. And this one's fairly straightforward and fairly simple to understand, and especially easy if we think of it in terms of an analogy to water flow. So let's say we have a couple of pipes, and let's call this has a flow rate of 1 and this has a flow rate of 2, and these two pipes join together. And over here we've got a flow rate of 3. If we've got water coming into this pipe, in through this pipe, and water coming in through this pipe, and then they join together, you know that the water, it's not going to, the amount of flow is not going to change. And so the flow 1 plus flow 2 has to be equal to flow 3. And then going the other way, if we have a junction in the pipes over here, and some of the water goes down this pipe, let's call that F4, and some of the flow goes down this pipe, let's call that F5. Well, that flow of F3, that water that's going in F3 gets split to 4 and 5, so the flow through 4 plus the flow through 5 has to equal the flow through 3. And it's the exact same thing with electrical circuits. If we're dealing with just wires with current flowing through them, if we have current 1 in this wire, and we have current 2 in this wire, and this wire here, let's call this current 3, I1 plus I2, which are the currents going into the wire, into this node here, I should say, that has to be equal to the current going in I3. And then similarly, if we have a junction over here where we have a split, let's call that I4 and I5, that I3 gets split between I4 and I5. And so the current over there, the current going into this node has to equal the current coming out of the node, I4 plus I5. And this applies to all circuits, not just ones with 3 branches coming out of a node. Let's say we had a much more complicated node here. And let's say we have 5 amps here, and 3 amps here, and 3 amps here, and 2 amps here, all going into the node. The current going in is 5 plus 3 plus 3, so 8, 11, 13 is 13 amps. There has to be 13 amps coming out. So let's say over here we have 5 amps, and here we have 4 amps, and here we have some unknown amount. Well, we know that the current out has to be equal to 13 amps. So we have 5 amps coming out, and we have 4 amps coming out, and we have some unknown amount coming out. Just rearranging this equation, to make this equation work, X has to be equal to 4 amps. Now I'm going to throw a little curveball at you with this application of Kirchoff's current law. Again, let's say we've got this node here with 4 branches coming in with currents going into the node. And let's say if we got 5 amps and 2 amps and 7 amps and 3 amps. And then let's say over here we've got 3 currents coming out. Okay, well, let's take a look at the current in first. So the current in is 5 plus 2 is 7, plus 7 is 14, plus 3, we got 17 amps going into the circuit, into the node. Now let's say over here we've got 10 amps coming out of that branch. We have 9 amps coming out of this branch, and we have some unknown amount coming out of that branch. Well, our I out is equal to 10 plus 9 plus y. Well, from Kirchoff's current law, we know that that has to add up to 17. 10 plus 9 plus y equals 17. Well, the only way that this equation is true is if y is equal to negative 2. Negative 2 amps. And that's fine. This is a totally legitimate application of Kirchoff's current law. We said where we've defined current as coming out of y, or out of this branch, which we've called y, and we've calculated that y is minus 2 amps. What that means is that current is actually going into the node there with a magnitude still of 2 amps. It's just going in that direction. So that's all I wanted to talk about. And Kirchoff's current law is really a fairly straightforward law. There might be curveballs thrown at you like this, but the fundamentals are that the currents going into a node has to equal the currents coming out of the node. Now I know you'll find all sorts of places where you can apply KCL, and I look forward to showing you in future videos all those different applications. Thanks so much for watching. See you next time. I can't do that. I'm not very good. There's not very much room here either. You can't see, but there's not that much space for me.